In this video, I will briefly talk about decrypting Scytale ciphertext using dynamic programming. A Scytale is an instrument used to operate a transposition cipher consisting of a cylinder with a strip of parchment paper wound around it on which is inscribed a message. The receiver uses a cylinder of the same size in diameter on which the parchment is wrapped to read the encrypted message. Ciphertext is the result of encryption done on plain text using a specific algorithm called cipher. On the right side is an example of ciphertext using the Scytale algorithm. In this video, I will be using dynamic programming to decrypt a Scytale ciphertext. Dynamic programming works by simply saving the results of the subproblems so that redundant computations are not needed in future computation. Dynamic programming reduces time complexities from exponential to polynomial. The word break function that is shown in the slide is using dynamic programming. The subproblem computation is stored in the lookup list. -1 means that it hasn't been computed, and it will be changed to 0 or 1 whether if the words is found in the local dictionary or not. Here is the main program, and the first part is stating a local dictionary. For testing purposes, I'm using a 35-word dictionary, with strawberries being the longest word, having 12 characters in length. The second part of the main program is testing all the numbers of loops of the Scytale band and applying word breaks function to decrypt the message. The time complexity of the word breaks algorithm using dynamic programming is O(n) times s, n being the length of the input string and s is the length of the largest string in the local dictionary, and can be simplified as O(n) squared, assuming the length of the input string is always longer than the length of the longest string in the local dictionary. Combined with the brute force algorithm to determine the number of loops of the band, the overall time complexity to decrypt a Scytale ciphertext using dynamic programming is O(n) cubed. Compared with the time complexity of the word breaks algorithm using the normal recursive approach, which I briefly discussed in the paper, and that is O2 to the power of n times s, simplified as 2 to the power of n times n with the same assumption as above, combined with the brute force algorithm, making it 2 to the powers of n times n squared. Therefore, the use of dynamic programming in the word breaks algorithm reduces the time complexity from exponential to polynomial. The code that is used in this video and the paper discussing about it can be found on the link. Thank you for listening.